so what we spoke about on Monday was drawing graphs, working with our coordinates to get some sort of visual representation of our relationship. Now, what we're essentially going to do now in this last lesson is we're going to go through this all, make sure we understand it, and just recap everything we've spoken about. So if we have a look at this table that I've given you, just make it a bit bigger. If we have a look at this table, we want to essentially find the pattern to our output values, and we want to continue this pattern to get the rest of our inputs. So guys, remember I've spoken about the fact that if we haven't been given a rule, what we want to do is we want to look at our outputs and we want to try and figure out how am I getting from one output to the next? What is the pattern? Am I adding something each time? Am I subtracting? Am I multiplying? What am I doing? So if we have a look at this table, we can see that we've gone from an output of 3 to an output of 1. So that's a subtraction of 2. I've then gone from +1 to -1, which is also a subtraction of 2. From -1 to -3, a subtraction of 2. And so what we see is that our pattern here, if we now look at this question A, is a subtraction of 2. We are subtracting 2 each time in order to get our output value. So if you were asked to describe the pattern in words, that's exactly what you do. You tell me what you're doing to get your pattern. Now, some of you like to say adding -2. That is absolutely fine. It means exactly the same thing. So if you say subtract 2 or adding -2, that's fine. It means the same thing. You've got the idea of the pattern. That's sorted. Right, so if we now know what our pattern is, we can essentially go and finish off or complete our table. So if I subtract 2 from -5, I have -7. And if I keep subtracting 2, I'm essentially able to get all of the outputs that I'm missing in my table. So I'm able to get the next output and essentially carry on getting outputs until I want to stop. Now, as we've discussed, that's all fine. That's all okay. But if I asked you, say, for example, for the 28th term, you don't want to sit and subtract 2 28 times to get there. And so what we need to be able to do with our pattern is we need to be able to answer a question like what B is asking, writing down an algebraic rule. So remember, an algebraic rule is one where we use X and Y to tell us what operations are happening to our input to get our output. Excuse me. And if you think back to number patterns, we also spoke about this in the context of using Tn and N. But for now, we're just going to use X and Y because this isn't, sorry guys, it's been a long day. This isn't number patterns. This is working with functions and relationships. So we stick with our input and our output. Now, remember I told you that the trick is when you are adding or subtracting a constant value. So here, this is what we call a constant difference. If we are doing the same thing every single time, adding or subtracting the same value every single time to get from one term or from one output to the next, that is where we, that's where we start with our rule. So we start our rule, and our rule will always be y equals, and then things happening to x. We start this by saying whatever my constant difference is times x. So just to refresh that, our constant difference is the value that we're adding or subtracting each time. So this, in this case, -2. And we start our algebraic rule by timesing that constant difference with x. Okay, that is our starting point. That -2 is obviously very important to us. It's the pattern, and so it has to be in our rule somewhere. Oh, right. From there, we now need to decide, is there anything that I still need to add or subtract in order to get my output? So this is now where we need to do a bit of a check. Whoops, I don't know what's happening. Sorry, this thing is moving all by itself. Anyways, if we take our input of 0, okay, so that input of 0 I'm getting from this very first column in my table. And I apply the rule that I have so far. So y equals -. -2, oh, come on, no one's fighting with you. -2 times 0. So that's what I have so far, according to my rule. I get a y value of 0 because 0 or -2 times 0, 0 times anything is 0. But remember, that's not what we want. We want an output value of 3. So the question is, how do I get from y equals 0 to an output value of y equals +3? Well, the answer is, in order for me to go from 0 to +3, I need to add 3. That's the only way I'm getting from 0 to 3. And so what that's telling me is that to my rule, I'm likely going to have to add a +3. So I keep the -2x, but now I add 3 to it. Now remember, grade 8, we always double check ourselves. We never just want to assume that what we've done is correct. We always just want to make double sure. So we check ourselves here. We pick another input value. So let's pick the input value of 1. You can pick any one, it really doesn't matter. And we check. So if x is equal to 1, we want a y or an output value of 1 as well. So we apply our rule. Y is equal to -2 times 1, because that was x, plus 3. -2 times +1 is -2, plus 3 is +1. And so because I'm getting the output value that I wanted, I know that this rule that I've gotten or that I've written down is correct. So when we are trying to find a rule for a pattern, what we want to do is we want to essentially start with what am I adding or subtracting, and then see, is there anything else that still needs to be added to this rule in order for us to get the correct outputs that we want. Alrighty, so we have been able to describe this in words. We have been able to continue our pattern or continue the outputs in our table because we know what the pattern is. And we have been able to find a rule. Now, all of this was done in patterns, and that's why I'm saying to you guys, if you're feeling uncomfortable, go and watch the patterns videos. The focus of this course, however, was being able to draw graphs. So what we essentially now want to do is we want to take all of these input and output values that were given to us in the table, whoopsie daisies, and I want to be able to plot a graph with that information. So what I'm going to do is I'm actually just going to copy this table down for us so that we don't have to keep scrolling back and forward. It's going to be a bit of a situation, but it's fine. Because now we are being asked to draw a graph to represent the relationship between x and y. It's clearly wanting to fight me today. All right, so there's our table. There's our x and y values. We want to draw a graph now. I won't let you take screenshots just now, guys, but let's just finish off this first example. So what you need to remember from Monday's lesson is the fact that anytime we want to draw a graph, we are working with a pair of coordinates. Now, these coordinates are x and y coordinates. Now, remember, there are important features to your graph that you need to be able to draw, or that you need to be able to add to your Cartesian plane, depending on what you're given. And so if we just sort out our Cartesian plane to start off with, we know that our horizontal axis is our x-axis, our vertical is our y-axis. We know that the point where they meet is 0, and we know anything to the right of 0 are all our positive x values. Anything then to the left of that 0 or that origin point is then our negative x values. So we fill in our values on our set of axes so that we can eventually plot the points we want to plot. So that's our x values. For the y values, anything above 0 is positive, makes sense, it's going up, it's positive. Anything, however, below 0 is negative. We're going down, it's negative. So once we've got all of that, we can now start to plot our coordinates. Now, guys, remember the coordinates you are getting from your table or you are getting from substituting into whatever rule it is that you have worked out. So if we have a look at our coordinates that we've got, the coordinate pairs, remember, have to be x, y. So the very first coordinate, according to our table, is the coordinate 0, 3. The first input was 0. The output there was 3. If we look at our second one, our input is 1, our output is 1. And we can keep going along our table and writing down our sets or pairs of coordinates that we are going to have to plot on our Cartesian plane. Now, you don't have to write them all out. I'm actually going to stop there. There's no need for me to write them all out. I have got them all in the table, so I can just use it from the table. But what you need to remember is that your input and your output form that coordinate pair. So now we start plotting. If we want to plot 0, 3, remember all of the first numbers are x's, the second numbers are y's. So we go to 0 on our x-axis, which is here right in the middle where they meet. We go up to 3 and we plot our point. That is the point 0, 3. It's 0 because it's on the y-axis, and it's up to 3 because that was our y coordinate. If we then want the point 1, 1, we go to 1 on the x-axis, up to 1 on the y-axis, and we plot our point. And so we keep plotting points until we've plotted all of the points that we have been given in our table. Because we hopefully remember that because this is the constant difference relationship, we know it should be a straight line. A straight line, technically, you only really need 2 points. You don't have to plot all of those points. So I'm not going to finish plotting all of these points in the table. That's just, I don't need to. I've already got more or less what my general sort of shape is. There's no need for me to carry on. But generally, 2 or 3 points, you should be okay. Now, because we're drawing a graph, we know that what we want to do is we want to join this with a line. Remember, the line has arrows on the end to show that this line does actually continue. And let's try to get this line a bit better. This line does continue all the way up to positive and negative infinity. And so we have a straight line. Right now, a couple of things to notice. Remember, our pattern, the important aspect of our pattern was the fact that we are subtracting 2 each time. If I go from point to point, we are decreasing, or we are going down by 2 blocks. There's that -2 that we discussed. If I now go down from the second point to the third point, again, I've decreased by 2 blocks. And so that pattern, or that constant difference that we saw of subtracting 2, is shown here on my graph. We also know that it's negative because what we see is that my graph is decreasing from left to right. And so that is why my rule had a negative 2x. That negative 2x means that we are decreasing from left to right. So, like I say, a graph is another way to represent this relationship. From the graph, I can tell that I'm decreasing by 2 each time. I can tell that this is a decreasing relationship. So as my x values are increasing, my y values are decreasing. And so just from looking at a graph, I'm able to start to see what sort of relationship I have. Right, so I'm going to just go back up to these first 2 for you to take a screenshot, and then I'll go back to the graph. While you guys are taking screenshots, if anyone has any questions, now is the time to raise your hand and ask. And remember, guys, you can always use the chat for questions. Watobe?
Ma'am, I wanted to ask Lucy that at the end, why do we put the arrow in the Cartesian plane?
On the graph, on that orange line that I drew.
Yes, ma'am.
Okay, so that's basically to show that that straight line, I could keep going all the way down to negative x, and I can keep going all the way down positive x.
Oh,
so technically, I can have any input value. I could go up to 40 million. It's because it goes on to infinity. Zianda? Zianda, are you there? Okay. Akani?
Hello, ma'am.
Hi.
So, ma'am, I'm just asking if the graph will be in our exams.
Excuse me, ask that again, sorry.
Is this graph gonna be in our exams?
So guys, remember, the only stuff that is in your exams is what you have done at school. We follow the lesson plan according to the government, but your school doesn't necessarily do that. So if you haven't done graphs, it won't be in the exam, and that's why we do the boot camps, because the boot camps will be the stuff in your exams.
Yes, ma'am. Thank you.
Okay. Grade 8, I am not re-explaining anything. If you were late, that is unfortunately on you to go and watch the recordings. So if these are hands to re-explain something, you are welcome to lower it. Belinda? Guys, please remember, if you don't unmute, I'm moving on. There's a lot of people with hands and I don't have time to wait for you. All right, Asake? Asake?
Yes, ma'am.
Yeah, question.
Yes, ma'am. Can I please ask if 0 has an invisible one?
If what has an invisible one? 0.
Yes, ma'am.
I suppose it does, but it's not going to make any difference. 0 times anything is still 0, so we don't really consider it.
Okay, thank you, ma'am.
But yeah, I suppose it does. Okay, and then Tshegofatso?
So ma'am, I was asking if are we going to get where we have to plot shapes inside the graph?
Sorry, did you say shapes? Oh, and then you muted. Tshegofatso, did you say shapes?
Yes, ma'am, shapes.
Yes, you can. So it's sort of a different section. It's not quite functions, but yes, we can draw shapes on our Cartesian plane. So we will eventually chat about that. Yeah. All right, those of you not understanding the graph, I'm just going over it very quickly. But essentially the graph is we have taken this table of X and Y values. So up here, we've taken the whole table. And what we have done is we have gone and plotted those points. So all of those points became coordinates, and then I just plot them on the graph. So if you don't understand the plotting part, you need to go and watch the first video of this course. All right, so Yandile, understand when we're putting it in a sentence, how do we describe the functions? I'm not really sure I understand what you mean by describe the functions, but I suppose if you're asking how do we describe like the shape, or how do we describe what we're looking at, then essentially what we need to do is we need to look at exactly what I've said, the shape of the graph. So this graph is decreasing. I know that it is decreasing by 2 each time because I can see that from point to point, I'm decreasing by 2 blocks. Point to point, I'm decreasing by 2 blocks. So that's where that minus 2x is coming from. So yeah, we need to be able to look at a graph and understand the relationship. It's very rare that we ask you to take a graph and then describe it in words. More often than not, what we do is exactly what we did here. We give you a table, we give you a pattern, and we ask you to describe that pattern in words, not really a graph. Excuse me. Right, last question, Reese.
Excuse me, ma'am.
Your hands up.
Yes, ma'am. How do we
Yeah,
get
what's your question?
How do we get the coordinates of 0,3, ma'am?
Okay, so the 0, 3 is from our very, very first input and output in the table. So I'm just gonna make this bigger. So here in this table, we've got the output of 3 and the input of 0. So that's my first coordinate.
Okay, thank you, ma'am.
Sure. Samtanda, I don't know what you mean by do we need to remember the graph? You will draw a different graph every single time based on the equation or the rule that you're working with. So you don't have to memorize this specific graph. The graphs change according to the rule. Amangalisi, yes. Basically the rule is for us to figure out any input, any output, we can get it from the rule. That's why a rule is so useful. Right. Good, grade 8. Let us have a look at another example. Actually, sorry, I don't think I've waited long enough here for you guys to take a screenshot. So take a screenshot of the graph and then we'll have a look at another example. Right, I'm assuming we've all got our screenshots. Let's have a look. So we're going to do a very similar thing here. Oh, that's a bit of a double negative situation going on here. I actually want to change my outputs. I don't like those. Right, so we're going to do a very similar thing. We've got a table, we've got some outputs, we've got inputs, and we want to essentially figure out what our pattern is. Guys, let's also just remember our manners when we're trying to help each other, when we're trying to answer questions. Yeah, unfortunately, much in the same vein as people who are distracted on the chat, those are rude, I will also remove you. All right, so I apologize, I did change my output numbers. I wanted to show you something with our graph and we'll eventually get there. So what we've got is outputs of 1, then 2, then 3, then 4, then 5. And so hopefully what we can see is that we're just adding 1 each time. So again, when it comes to question A, describe the pattern above in words, we are adding 1 each time to get from one output to the next. Now this means we can carry on this pattern. If I continue to add 1, I'm going to get the next term. So if I add 1, I get 6. If I add 1, I get 7, then 8, then 9, etc., etc. So I'm able to fill in the table. I'm able to continue my pattern the second I know what the pattern is. So again, we want to write out this rule. So I want you guys to write out the rule for me. So remember, the rule is going to be something along the lines of y equals, and then we will have our rule. Excuse me. So give it a try. We've discussed what the pattern is. We've discussed that we're adding 1 each time. Try and find the rule for me. Give it a go. Put it on the chat. And grade 8, again, if you are not doing this in school, that is fine. It just means you've got a head start. There shouldn't be any hands. If you've got a question, remember to put it in the chat. Grade 8s, I'm not asking you to describe the pattern. We have done that. I'm asking you for a rule. Y equals something to do with x. So like we had in the last example, minus 2x plus 3. That is what I want. I can see the answers coming through. Keep it coming. I don't want a description. I want a rule. And remember, check yourself. If you're not sure about your rule, substitute in. See if you get the correct output. Right, would anyone like to raise their hand to give us the rule, to explain how they got the rule? Sanduake?
Oh, ma'am, I said, ma'am, also y will equal to 1x plus 1.
Okay, perfect. Sorry, my brain didn't want to function there. Exactly. So guys, remember I said the trick is that whatever you're adding each time, that is what you times by x. So we're adding 1 each time. So I say 1 times x. You could write it as x if you want, that's fine. And then that isn't taking us to our output. If we take our first one and we substitute in x equals 0, y is equal to 1 times 0 gives us 0. I still need to add 1 in order to get the output that I want. And so that's what Tandawake told us, y is equal to 1x plus 1. If you wrote this as y is equal to x plus 1, that is absolutely fine, but so is 1x plus 1. Both of them are perfectly fine. All right, so now we've got our rule. And what that means is we've got our rule, we've got a description, we've got our table, we've got a lot of information about this relationship. We can now go and draw our graph. So again, what I'm going to do is I'm going to bring this table down. Sorry, I just want to move this, otherwise it's going to be chaos. All right, so I'm going to bring our table down for us. And then we're going to plot some points. Thank heavens for technology, and you can just move things around when you want. Alrighty. So there's our Cartesian plane. Remember, x and y axes. So x is horizontal, y is vertical. We need to put our numbers on. I know I complained about this last lesson, and I still didn't go and add my numbers. Right now, remember, guys, so some of you were a bit confused about where we got coordinates from in the last example. The coordinates come straight from the table. You take the x, you take the y, that is the coordinate that you plot. That is what a coordinate is. A coordinate is a set or pair of x and y values that correspond to each other. They follow the rule. We've taken the input, whatever that x value is, we've applied our rule, and we've gotten the corresponding output. That is what a coordinate does. It gives us input and output values, just now visually. Whoopsie daisies. So what we now want to do is plot our coordinates. So if I take my first one, and maybe if we color code this, this will hopefully help those who are feeling a bit confused. If we take our first coordinate pair, x is 0, y is 1. So I go to where x is 0, right here in the middle where they meet. I go up to where y is 1, and I plot my point. That's not a great point. Let me try that again. And I plot my point. If we now go to our next set of coordinates, the next pair is now 1, 2. So my x is 1, my y is 2. I go to where x is 1, I go up to where y is 2, I plot my point. My next coordinate is now 2, 3. So x is 2, y is 3. I go to where x is 2, I go up to where y is 3, and I plot my point. Now, guys, again, you don't have to keep going. I'm going to do one more, but I'm starting to see the shape of my graph, so I don't need to do an excessive amount. My last one that I'm going to plot is the coordinate 3, 4. So I go to where x is 3, I go up to where y is 4, and I plot my point. And so what I see is now I've got this general shape of my graph. And this is now where I add in my line. Again, as I've explained, I will fix my line now. As I explained, the line has those arrows on the end because it's showing that, no, I know how to do this. It's just fighting with me. Okay. Because it shows that this graph can just keep going. It can just keep extending. And so in answer to the question, if there's no negative numbers on the table, you don't need to add it to your graph, but by extending your line, you are showing that there could be negative numbers if this rule went in the, I don't want to say the opposite direction, but if we started using negative input values. So I wish I could draw my line a little bit better. Let me try this line again, because this is a really cool question. So the question is, if there are no negative numbers on your table, do you need to add negative numbers to your graph? The short answer is no, you don't. But the longer answer is you can use your graph to go and figure out what they would be. I can't draw a straight line today. Okay, there we go. That's a bit better. All right, so in answering this question, excuse me, if we then introduced, let's say, an input value of, I don't know, -2. We know our rule is y equals x plus 1. And so we could algebraically, or using our formula, we could work out what our y or output value is. We substitute in the -2, so -2 plus 1 is -1. If we now go to our graph, we can actually read that off our graph. Where x is -2, I read down, I then read across, and I get my output of -1. And so this is what I'm saying. No, you don't have to plot negative points, but you could use your graph to go and read off those negative values. And this is why graphs are so cool. We can extend, or we can go further than what just a table shows us, or what just a description shows us. We're able to use it to find out more information. Excuse me. Why are you not going upwards and going diagonal? I don't really know what that means, if I'm being completely honest. I don't know what would be going upwards and diagonal. If you can explain that a little bit better to me, then I can try and answer that. But the line is going diagonal because the dots are moving in sort of moving. The dots are placed in a diagonal direction. Right, now guys, what I want you to notice, and I'll let you take screenshots now in a second, is if we go back up to this first graph that we drew, this is a graph that was based on the rule, or that came from the rule, and let's just get a highlighter here because I know it's a bit small. Y equals -2x plus 3. And I said to you that this minus sign results in my graph decreasing. So we can see it's going down from left to right. If we now compare that to this graph, this is definitely not a decreasing graph. We can clearly see that this graph is now increasing from left to right. And this is because if we go back to our rule, the number in front of x is positive. So when that coefficient, when the number in front of x is positive, it is increasing, where it is a line that increases from left to right. And so again, this is now a description of our pattern. We have got a pattern that as your inputs increase, your outputs are also increasing. And so we're able to start seeing this relationship visually and then putting it into words. Lemon Pepper, I'm still not understanding. So I'm gonna get everyone to take screenshots and then ask questions. So please raise your hand and try and help me here. I am having a bit of a day and my brain is not functioning as well as it could be. So it might just be me. So just help me out in a second. Right. Take screenshots here, guys, if anyone has any questions. So yeah, please do raise your hand and ask me. And then hopefully we're going to be able to look at quite a cool graph.
So I just wanna clarify some things to some of you. Please know that if your screen freezes or if anything, without us mentioning anything to you on the chat that maybe we're experiencing network problem, it could be that it's your network. But please do not panic because we are recording this for you, okay? And for those of you who are struggling to see the screen, we always tell you to log out and then come in again. Okay, my people? Let's go.
All right, I'm gonna eventually slide down lower to the graph. I'm just waiting for everyone to take screenshots here. Omolemo, how do we get from negative to positive on the graph? Hopefully when I get to the graph, I'll be able to answer that. I'm also not entirely sure if I understand, but we'll see. Orteng, thank you. Hopefully that's helping. Yes, you plot the points according to you draw the line according to the points you've plotted. So if the line or the points are going diagonally upwards or diagonally down, that's the line you draw. And Dile, whoopsie, there we go. Question?
Ma'am, do we go like up or down on the increase?
Okay, so when we are trying to decide if it's increasing or decreasing, we always read from left to right. So like you would read a book, we read our graph from left to right. So if we start on the left-hand side and we go to the right, we can see that we're starting at the bottom and we're moving up. And so that means it is increasing. On the other graph that we did, if we started on the left and we went right, it was decreasing. So that's a decreasing graph. Does that help?
Thank you, ma'am. Yes.
Good. Limpopo, I'm so glad, because clearly my brain was not functioning. I'm glad that helped. I don't know if what I said helped at all, but well done. Wotale?
Ma'am, you see by 1x, I see why y equals to 1x plus 1. Ma'am,
Yes.
did we get that one because, ma'am, like in each variable, if it doesn't have like a number in front of it, there's an invisible one, or?
Oh, you're breaking up. I don't know if I got all of that. So are you talking about a number in front of this? In front of the x, sorry.
Yes, ma'am. Like if we don't get a number in front of the x, is there like always an invisible one, or?
Yeah. So anytime that you have a letter and there's no number in front of it, it is always 1. And that's why I said when we did the rule earlier, you could write it as 1x plus 1, but you can also write it as x plus 1, because there's that invisible 1 there that we don't have to write in, but it is there. Right. And then so Malezi, when it's diagonally going down, it's negative. Exactly. So if my graph was going diagonally down, I'm just going to draw a random line like that, it is a negative function. It is decreasing from left to right. Very, very well done. Right, so guys, I'm hoping you've all got your screenshots. Ooh. Okay, so let's take a little break. I don't know if we'll do a whole brain break. We'll see how far you get with this. And then I'm going to show you a really cool graph. And just to show you that the lines don't always have to be straight. Like with anything, just because we have been doing straight lines, that's because I said to you mostly in grade 8 and grade 9, that's what you work with. But your graphs don't always have to be straight. And so if you decide to do maths in grade 10, grade 11, grade 12, you're going to see some really cool shapes of graphs. So let's take a little break. We'll see. Let's put a time cap on this. So at 5:50, so 1750, if we don't have an answer, then we will move on to our graph and we will just carry this over to Monday. I also need to get an answer. Haven't seen an answer yet. I'm glad we appreciated the joke.
Let's go, guys. Let's go. Yeah, the joke. The joke is really funny, guys. Which channel is the coldest? Yes, Mivuyo has won today's quiz day. Nice, Mivuyo.
Nice. Mavuyo, do you want to raise your hand?
Nice, guys.
Hey, Mavuyo, tell us.
Ma'am, I said 10 plus 10 plus 10 equals to 30.
Good.
And then since it's the one leaf, so I said 5 times 5.
Good.
and plus 9
Good.
equals to 34. And I said 9 plus 9 times 10 equals to
Good.
99.
Excellent.
Then 10 plus 9 times 10 equals to 100.
Excellent. Well done. So guys, remember BODMAS, 9 times 10 is 90, plus 10 gives us that final answer that Movuyo gave us of 100. Well done. That was so nice and quick, Movuyo. Excellent. Alrighty, guys. So hopefully we've all had a little stretch. We've all given the brain break a try. Excuse me. And now we're going to have a look at some cool graphs that we can get. Ma'am, what for the... Okay, so you can't use different... Okay, so Kotatsu, you can't use different numbers for the first one, because what you need to realize is that because these pictures are all identical, you have to be adding identical values. There's 3 identical numbers that we're adding. So it has to be 10 plus 10 plus 10. The pictures are representing that it's the same number. All right, guys, so let's do this. If we have a look at quite a cool situation, I'm just scrolling down a bit. We're going to have a look at this table over here. So consider the relationship, etc., etc. Same as what we've been doing. Let's have a look and see. So we've gone from -9 to -4. So I have added 5. I've then gone from -4 to -1. So now I'm adding 3. I've gone from 1 to 0. So I've added 1. And now what I see is that I'm going from 0 to 1, which is -1. So I've almost continued a pattern, and now I'm following something else. So these are patterns where we don't necessarily have the same number that we're adding or subtracting each time, but it doesn't mean that there isn't a relationship. So if I now carry this on, we can see that it was +1, -1. So my next one is going to be -3, +3, -3. So this would be -4, because -1 minus 3 is -4. Again, look at the pattern. I'm going to -5 now. So this would be -9. If we now went a step further, we can see that we're using odd numbers. And so this would be a subtraction, or a -7, which is -16. All right, so what we need to realize here, is that this isn't the same as the patterns we've been talking about. We're not adding or subtracting the same thing each time. We are adding a different value each time, but essentially, as as we can see on the chat, what we have here is a situation where if we now look at those letters, those numbers that I've written in blue, we can see that each time I've subtracted 2. So I've got odd numbers, and to get from one to the next, I'm just subtracting 2 each time. Now be careful, this is not a constant ratio. A constant ratio would be me timesing or dividing the same thing each time, but there is still a pattern. So if we wanted to describe this pattern in words, we could say that we are adding consecutive, so consecutive means one after the other, odd numbers. And that's essentially what I'm doing. Initially I added 5, then I added 3, then I added 1, then I added -1, then I added -3. So I'm now working with consecutive odd numbers. All right, I'm gonna leave this rule situation for a second. I want to draw the graph so that we can see what this means. So again, we're adding consecutive odd numbers, 5, 3, 1, -1, but it's all odd numbers. So Somolezi, must the rule be the same? It doesn't have to be. I don't have to be adding or subtracting the same thing each time. It just means that when I draw my graph, it's not going to be linear. So it's not going to be a straight line. Okay, guys, so we'll come back to the algebraic rule in a second. I want to draw the graph so we can see how cool this is and what it looks like. So again, I'm just going to take this table so that we can actually draw the graph. Junior, consecutive means one after the other. So consecutive numbers would be 1, 2, 3, 4, 5, 6, etc., etc. Consecutive odd numbers is then 1, 3, 5, 7, 9. So consecutive means one after the other. Right, guys, so we know how to do this at this point. We have been drawing graphs until they come out of our ears. We take our graphs, we plot our points, and we're getting some sort of picture. So our first coordinate pair that we've got is -3, 9. And once again, I have made choices that I don't understand why I made them, but I did. Oy vey. Right, so while I'm doing this, hopefully what you'll see is that I'm not going to have space for a -9. Now, that's not the end of the world. Just because I can't plot all of my points doesn't mean that I'm wrong. It just means on my Cartesian plane, I haven't given myself enough space. So I'm going to move to the next coordinate. So the next coordinate pair is -2, -4. I can definitely plot that. I've got enough space. So as soon as I put my negative x's on, I can plot that. Getting there, right. So my x is -2, so I go to -2 on my x. I go down to -4, and I plot my point. Let's try that point again, and I plot my point. The next coordinate that I have is -1, -1. So I go down -1, down to -1, plot my point. I also have regrets about doing this in the same color as what I've done. So let me do this like this. There you go. Right, the next point that I have is 0, 0. So that is through my origin. I plot my point on the point where the axes meet. Then I continue plotting my points. My next one is 1, -1, 2, -4, and again, 3, -9, I can't plot. So this graph looks a little bit weird. It's sort of like going up and then it's going down. This is what we call a parabola. You don't need to stress about that name. But this is a graph that isn't necessarily a straight line. This is one that is a curve. It doesn't look like a curve because apparently I can't draw a curve tonight. This is one that curves, and this is because of the pattern that we had. We weren't adding or subtracting the same thing each time. We were consecutive odd numbers. That was our rule. That was our pattern that we saw. And so, again, what I need you to realize is that the graphs that we draw won't always be straight lines. It very much depends on the pattern that I'm working with or on the rule that I'm working with. And so because this rule was a little bit different, as we said, the rule does not have to be the same. So I don't have to be doing the same thing from one value to the next. I get a slightly different looking graph. Alrighty. So it doesn't really matter. If you want to take a screenshot of the graph, you're welcome to do that.